Okay, so let's talk about this idea of linear and angular speed. Well, when we say speed, what I really want to talk about is our linear to angular measure, right? And we're talking about going between arc length and radius. Here's our formula right here. The arc length on a circle is equal to the central angle when measured in radians times the radius. And this is very important, right? Because if you think about the way things actually work in the world, right? If we were to look at a picture of the Earth, it would be, well, roughly circular. But for our purposes, we'll treat it that way. And if we wanted to measure the distance between two cities, let's say on a north-south axis right here, I might be saying that, well, okay, if city A is here on the globe, and city B is here on the globe, we can't rightly measure that distance using a straight line. After all, the Earth is curved, so we should be getting an arc length. So if I was interested in actually measuring the distance between these two cities on a north-south line of the globe, I would actually want to know something about the radius of the Earth and then the angle between the two cities in radians. And that's what this formula says. If I'm interested in this distance, which we'll call S, we need to know a couple of facts. The angle in radians, and we need to know the radius of the Earth. And it'll probably be in miles, right? So we'll go ahead and put it in miles so that we can put it in terms that we know. So what should we do? Well, let's get a little bit of information right here. Let me give you a problem. So here's a little bit of information. Let's say city A is Miami, and it's located at 25.78 degrees north. And New York City, which is located at 40.75 degrees north. The radius of the Earth we can take to be approximately 3,960 miles. So how do we use that information to find the distance along the outside of the Earth from these two cities? Well, the first thing we're going to do is we're going to get our angle by taking the difference between New York City and Miami. So if we take city A minus city B, NYC minus Miami to get our angle, in degrees, we're going to take our 40.75 and subtract our 25.78 degrees and get our difference. Right, so carrying my 7 and 1, 15, that's a 7. Carrying a 39, this is 17, this is 16, so that's a 9. Let's see, this is going to be 39, 4, 14 degrees, 14.97 degrees. Okay, so let's say that my problem is that I'm going between New York City and Miami. I know that New York City and Miami are located at 25.78 degrees north, New York City at 40.75 degrees north, and I'm interested in finding the distance between these two along the circle. So the radius of the Earth, we'll take that to be approximately 3,960 miles. So let's take our difference. We will be subtracting our 40, our 40.75 degrees minus our measure of 25.78 degrees. And this is going to be our angle in degrees. So our difference right here, let me just go ahead and carry out the measure. You could probably do this by hand, but not too bad right here. We're going to take 40.75 and we're going to subtract from it 25.78, and we get a difference of 14.97 degrees. 14.97 degrees of latitude right here. So we're interested in figuring out what is the distance. Well, in our formula, the angle must be in radians, so our next step would be to convert this into radians. Let's take 14.97. We're going to use our formula right up here that says the angle in radians is pi over 180 times the angle in degrees. So multiply by pi, divide by 180 degrees to get our angle in radians, and I'll go ahead and carry this out on my calculator. 14.97 would be multiplied by pi, and then divided by 180, and I get approximately 0.26 radians. So we'll use that number, 0.26 radians. Well, now we use this measure right here to get our measure of our arc length, which is our distance along the edge of the Earth between these two cities. Going in a direct north and south line, we would be multiplying 0.26 radians times 3,960 miles. And we're going to find our distance to be equal to times 3,960 gives us 1,034.65 degrees, so approximately 1,034 miles, rounded to the nearest whole mile. And this turns out to be a very useful technique because whenever we're calculating distances between 2 points on the Earth, we certainly would want to know it in terms of the trigonometry, not just in terms of straight line distances. So what's the connection here between angular speed and linear speed? Well, it turns out that if our measure here for arc length is S is equal to theta times R, we can say that, well, if you take the arc length and divide it by time, you've got a linear speed. Right? If I were to take miles per hour and I would divide it by miles divided by hours, right, I'd have a linear speed. And our angular speed is going to be theta divided by t, right? So we take our angle theta in radians divided by time t, that is called an angular velocity. And if we were to multiply that by the radius, we would have our connection. In essence, where we say that if our linear speed v and our angular speed omega, that's the Greek little w there, that's omega, times radius, that is our relationship between linear speed and angular speed. So, as an example, how does this work out? So let's say that we're told that the minute hand on the clock rotates at 1 revolution per hour. Right? We want to find the angular speed of the minute hand of the clock in radians per minute. Right? So what will we have to do? Well, first things first, of course, we want to get revolutions per minute, right? Because we're saying per hour right here, but we want radians per minute. So we need to make sure that our units are all alike. So in my case, here's what I'm going to do. I'm going to say, all right, I know that one revolution is equal to 2 pi radians, right? So I'm saying 2 pi radians per hour is how fast this is traveling, right? Now, we want to find out, well, what is this in terms of radians per minute? Well, it's 2 pi radians per hour, but we want to multiply that by 60 minutes per hour, right? Actually, we need to reverse that, right? Because we need to cancel out hours. We would say 1 hour every 60 minutes. Right? So if we want to think about it this way, 2 pi radians per hour is multiplied by hours per 60 minutes. So our speed right here is going to be 2 pi divided by 60, or if we care to reduce it, pi over 30 radians per minute. So how could we use this? So if we ask one more question and say we have a minute hand that has a length of 10 centimeters, find the linear velocity of the minute hand, well, here we are. Here's our formula. Our velocity is equal to the angular velocity times the radius. So we can now say that our linear velocity of the tip of this minute hand is going to be our angular velocity, and we've already said it's pi over 30 radians per minute, and we're multiplying that by 10 centimeters as our radius, and we get 10 times pi over 30, or more simply, pi over 3 centimeters per minute as our linear velocity. And so we're done. See you in class.